Okay, lesson 66, signs of fractions, and then 30, 60, 90 triangles. Signs of fractions. The rule here is that with fractions, we can change any two signs as long as we change two signs, and we will always end up with the same fraction. So we could change this minus to a plus and this plus to a minus, like they did here. Or we can change this to a plus and this to a minus, like they did here. Or we can change these two positives to negatives, like they did out here. So we can change with any fraction. Fractions technically have three signs: one sign out front, one sign at the numerator, one sign at the denominator. And we can always change two of those signs to the opposite sign, and the fraction remains the same. But we must always make sure we change two, not three, not one, two, exactly two. And our number will always stay the same. That helps us a lot when we come to adding complex fractions, because notice here, if we change this sign, we'll have a like denominator. If we can go positive x, then we'll match there, and negative 3. So if we change the signs on the bottom, signs of the denominator, and that means we change the sign of both terms, of the x and the 3. If we change those two signs, we end up with a like denominator, and we can then add, and things go easy from there. So we're going to work the two-class practice that are like that. Right there at the top. See if I can let some light. So 1 over z minus 2 minus 3m over negative z plus 2. So let's change the sign of this. If we change this denominator sign, we'll have like denominator. So we'll change this to a positive and this to a negative. So 1 over z minus 2. And we're also going to change this to a plus, so that we're changing two of the signs. We're going to change this middle term to a plus and change these two signs to z plus 2 over 3m. And then we're going to have z plus 2 on the bottom, and on the top, 1 plus 3m. We are done. Okay, doing another one. It's very simple. Here, let's change the signs in the first one, the denominator. So if we change this to a positive x and this to a positive 4, we'll match. So let's change this so that we have a positive denominator instead of a negative denominator. Now you could do it the other way. You could change this to a negative x and a negative 4, and that would work as well. But we're going to do it this way because I think it's nicer. Positives in the denominator. So we're going to put on the bottom x plus 4 and x plus 4. And we've got x minus 7. Keep this term the same. Positive. I'm going to change, instead of changing this to a negative, or this to, we would actually have to change this out front to a negative. Instead of changing this to a negative, I'm going to change both the signs up top. Change the signs of the numerator. And that will be a negative 3x, and we must change the 7 as well. Negative 7. And then over x plus 4, we have negative 3x minus 7 plus x minus 7 over x plus 4. Negative 3x and x join together to get negative 2x. Negative 7 and negative 7, negative 14 over x plus 4. All right, that's how to work those guys. Let's go, and I think we've got time, and work look at the 30, 60, 90 triangles. 30, 60, 90 triangles are triangles that have a 90-degree angle, a 30, and a 60-degree angle. It equals 180, and they're always set up with a 1, 2, 3 figure, the square root of 3. These sides always are in this scale. 1, 2, this one's twice as big as this one, and this one is the square root of 3 on that scale. Always remember to put your 1 and your 2 across from your 60-degree sign. It's a little confusing because we're used to learning that 1 squared plus 2 squared equals 3 squared. A squared plus B squared equals C squared. Whatever these two would equal this one. And this one seems to have the 3 here instead of on the hypotenuse. Always remember to put your 1 and your 2 across from the 60. And how that is shown to us and becomes very clear is if we have an equal-sided triangle that has 2, 2, 2, and we cut this in half, half of the 2 becomes 1. That's why we have our 1, our 2, and the square root of 3 right there with the 60 degrees in between. So 1 is always a short one, 2 is across the 60-degree sign, and the square root of 3 is in between. A way to work this is like this. This is the class practice one we have, copied down not quite so neatly, but as neatly as I could. So here's what they give us. They give us the right angle, and A and B and 7. Now, where is our 60-degree angle? Is our 60-degree angle down here? Is our 60-degree angle up there? Well, this one's shorter, so obviously our 60-degree angle is going to be here. Again, we can easily picture this as a complete triangle where we've got 2, 2, and 2. So our scale pattern is 2, square root of 3, and 1, like this. So it's similar to a triangle like this. Remember this thing. Remember it all the days of your life. Now, we do have information. We're going to solve for A and B. We do have information here that the square root of 3 and 7 relate. So we're going to go the square root of 3 times our scale factor. We're looking for the scale factor equals 7. So this times whatever we need to throw in there as our number equals 7. And then we'll divide both sides by the square root of 3, square root of 3, and we discover that our scale factor equals the square root of 3. And then we can plug that in to this equation to solve A. So 1 times our scale factor, which is square root of 3. What did I do? So the scale factor is not the square root of 3. The scale factor is divided by the square root of 3. Scale factor equals 7 over the square root of 3. Now we can plug this scale factor in and make this 1 times our scale factor equals A. So 1 times 7 over the square root of 3 equals A. A equals 7 over the square root of 3. So that's our A answer. And then for B, we'll work it the same way. 2 times scale factor equals B. So 2 times scale factor equals B. 2 times 7 over the square root of 3 equals B. So 14 over the square root of 3 equals B. All right, there's B. So A is 7 over the square root of 3, and B is 14 over the square root of 3. We've solved the class practice one. Remember, always put your 1 and 2 across from your 60-degree angle, and if you can just jot in or just imagine the rest of that triangle, it's going to help you know that these are all equal sides, and this is a 2 and this is a 1, and then your square root of 3 goes there. Enjoy.